Let's talk about how we can use trigonometry to solve for the missing side lengths and angle measures in a right triangle. Remember, in our previous video we learned SOHCAHTOA, which is a cute little sing-songy acronym that we use to help us remember what sine, cosine, and tangent are. The first part of this acronym is SO, S-O-H. S is for sine, and O and H are for opposite and hypotenuse, because sine is the opposite side over the hypotenuse. Ka is the middle part of the acronym, C-A-H. C is for cosine, and A and H are for adjacent and hypotenuse, because cosine is the adjacent side over the hypotenuse. And the last part of the acronym is TOA, T-O-A. T is for tangent, and O and A again are for opposite and adjacent, because the tangent is equal to the opposite over the adjacent. So how do I use sine, cosine, and tangent to calculate side lengths and angle measures? Well, if you know one angle measure and one side length in a right triangle, you can use either sine, cosine, or tangent to calculate a missing side length. For example, in the diagram that we have on the screen right now, I know that the measure of angle A is 35 degrees, and I know that the length of the adjacent side, AC, is 10 meters. If I wanted to calculate the length of the opposite side, which is BC, I would need to use tangent, because I'm looking for the opposite and I know the adjacent. That's O and A, so I would need to use tangent, or TOA, from SOHCAHTOA. So the equation that I'll write is what you see on the screen at the bottom. Tangent of, in this case, 35 degrees. Inside of those parentheses, you'll always write whatever the degree measure is, and you'll set that equal to the ratio, opposite over adjacent. The opposite side is BC, the adjacent side is 10. To solve, you would multiply both sides by 10 and get your answer. Let's try a few examples. The instructions ask us to calculate the length of JK, and in relationship to the 63-degree angle that we were given, JK is adjacent, and 14 is the side length that we were given. 14 is the hypotenuse. So since I know the hypotenuse, and I'm looking for the adjacent, that's A and H. So according to SOHCAHTOA, we need to use cosine. So the equation that I'll write is this: cosine of the angle measure, so cosine of 63, equals adjacent over hypotenuse. The adjacent side is JK, that's what we're looking for, and the hypotenuse is 14. To solve, I'll multiply both sides by 14, so get out a calculator and type in 14 times cosine of 63. Again, being sure that you are in degree mode. Some calculators default to being in radian mode. We don't want radians, we want degrees. So making sure that you're in degree mode, type in 14 times cosine of 63, round to 1 decimal point, and we find out that the length of segment JK is about 6.4 inches. Let's try another one. This time we're looking for the length of ST, and we're given the length of RT and the measure of angle R. In relationship to angle R, the 58-yard side is the adjacent side, because it's right there next to the angle. And ST, which is the length that we're going to calculate, is the opposite side, because it's on the other side of the triangle from the 31-degree angle. So since I have adjacent and I'm looking for opposite, that's O and A. I need to use tangent in order to solve. The equation that I'll write is tangent of 31. For these types of equations, you always start out with the trigonometric ratio, sine, cosine, or tangent, and then in the parentheses you write the degree measure. So tangent of 31 is equal to, and then you write a fraction, which is the ratio of the side lengths for this trigonometric ratio. For tangent, it's opposite over adjacent, so ST over 58. To solve, I'll multiply both sides by 58. Type that in the calculator and you'll get an answer of 34.8 yards. For our next example, we're asked to calculate the length of FG, and FG is the hypotenuse of this triangle. We're told that angle F measures 19 degrees and that the length of segment HG is 7. In relationship to the 19-degree angle, 7 is the opposite side. So since I have opposite, and I'm looking for the hypotenuse, the trigonometric ratio that I need to use is sine. So I'll write that the sine of 19 equals the opposite over the hypotenuse. To solve, we need to get rid of the fraction. And to get rid of a fraction, you multiply by the denominator. So I'm going to multiply both sides of this equation by FG. So FG times sine of 19 equals 7. Then I need to divide both sides by the sine of 19 and get my answer of 21.5 meters. You'll notice that the solving process for this problem was slightly different than the first two problems. It required an extra step. It was a little bit more work. The difference is where the variable ended up. For this problem, our variable is in the denominator, which means the first thing I need to do is multiply both sides by that variable, and then you'll have a second step of dividing by, in this case, sine of 19. But for the first two problems, our variable was in the numerator instead of the denominator. And that made it slightly easier to solve, because all you needed to do was multiply both sides by the denominator, which was a number instead of a variable. But you need to be prepared to solve either type of problem. Sometimes your variable will be in the numerator, sometimes your variable will be in the denominator. It just depends on the problem. So that's how we can solve for a side length using trigonometry. Let's talk about how we can calculate an angle measure using trigonometry. In order to calculate an angle measure, we need inverse trig functions, which are each of these. And on your calculator, you can find inverse sine, inverse cosine, and inverse tangent by using the second button and then sine, cosine, and tangent. You should see each of these above each of your sine, cosine, and tangent buttons. Inverse trig functions essentially undo a normal trig function. They get rid of it. It's how we'll get a variable that's inside of the parentheses of a trigonometric ratio alone and have it be solved for a. For example, in this diagram, I see that BC is 7 meters and AC is 10 meters. If I want to calculate the measure of angle A, well, 7 is opposite from A and 10 is adjacent to A. So opposite and adjacent, I would need to use tangent. We discussed in the previous few problems that you put the degree measure of the angle inside of these parentheses. But I don't know the degree measure. That's what I'm trying to calculate. So instead, you put a variable, the name of the angle. So tangent of angle A is equal to the opposite over the adjacent. So to solve for angle A, we would need to use inverse tangent. You would take the inverse tangent of both sides. So inverse tangent and tangent would cancel, and I would just have A. And I would take the inverse tangent of 7/10, put that in the calculator, and it would be my answer. Let's take a look at a few examples. We need to calculate the measure of angle S, which is marked with a theta. In relationship to angle S, TS is adjacent. This side is right next to the angle, and therefore it's considered adjacent, whereas 19, which is also adjacent to theta, has a special name. Since it's the side that's across from the right angle, we call it the hypotenuse. So since I have adjacent and hypotenuse, we need to use cosine in order to solve. So the equation that I'll write is this, the cosine of S. So in those parentheses, I can't put a degree measure this time because I don't know what the degree measure is. Instead, that's where I'll put the variable. I don't know the measure of angle S, so I'll just say cosine of S. And I'll set that equal to the adjacent over the hypotenuse, so 11 over 19. Well, my variable is trapped inside of the trigonometric ratio of cosine. To break it out, I'll need to take the inverse cosine of both sides. So this inverse cosine and the normal cosine cancel out, so I just have angle S. And on the right-hand side of the equation, I'm going to need a calculator to help me out with that. So I'll type second cosine to type in inverse cosine, 11 divided by 19. And I find out that the measure of angle S is approximately 54.6 degrees. Let's try another one. This time we're going to calculate the measure of angle V. 73 feet is the hypotenuse because it's the side that is across from the right angle, and 47 feet is the opposite side because it's on the other side of the triangle from theta. So since I have opposite and hypotenuse, we need to use sine. So the equation that I'll write is sine of V is equal to the opposite over the hypotenuse. So to solve for V, I need to take the inverse sine of both sides. The inverse sine and the normal sine will cancel out, and I just have the measure of angle V equals the inverse sine of 47 over 73. Type this into your calculator and you get an answer of about 40.1 degrees. And let's try one more. We're looking for the measure of angle Z. In relationship to angle Z or theta, 33 centimeters is adjacent and 20 centimeters is opposite. So since I have opposite and adjacent, I need to use tangent. So the tangent of angle Z, or the tangent of theta, is equal to the opposite over the adjacent. Take the inverse tangent of both sides, and we find out that the measure of angle z is equal to the inverse tangent of 20 over 33. And your calculator will tell you that that answer is about 31.2 degrees. So let's put all of this knowledge together to solve right triangles. To solve a triangle means to calculate all of its angle measures and all of its sides. For every problem, you'll either be given 2 side lengths and the right angle, or you'll be given 1 side length and 1 acute angle, as well as the right angle. Your goal when you're asked to solve a right triangle is to calculate the missing lengths, or the missing angle measures. So how do we do that? Well, some of it's going to involve trigonometry, and some of it's going to involve other stuff that's a little bit easier to figure out. If you know 2 side lengths, for example, you can just use the Pythagorean theorem to figure out the third. No trigonometry needed. If you know one of the acute angle measures, you can use the corollary to the triangle sum theorem to find out the other acute angle measure. Just subtract the one that you know from 90 to get your answer. Again, no trigonometry needed. But you will have to use trigonometry at some point, depending on what kind of information you're given. If you were given 2 side lengths, you're going to need to use inverse trigonometry in order to calculate an angle measure. And if you were given 1 angle measure and 1 side length, then you'll just use normal trigonometry to set up a trigonometric ratio and solve. So let's give it a try. The instructions are to solve the right triangle, so I need to figure out all of the missing parts. I need to figure out the measure of angle B, the length of AC, and the length of CB. The measure of angle B is the easiest thing to start out with because it doesn't require trigonometry. Since I know one of the acute angles of this right triangle, I can just say that the measure of angle B plus 33 degrees equals 90 degrees, which means the measure of angle B must be 57 degrees. But after that, I'm going to have to use some trigonometry to calculate the side lengths. It doesn't matter which side length you solve for first. Let's say I wanted to solve for CB. In relationship to the 33-degree angle that we were given, CB is opposite, because it's on the other side of the triangle. And the 47 meters length that we were given is the hypotenuse, because it's across the triangle from the right angle. So since I'm looking for the opposite and I know the hypotenuse, I need to use sine. So I'll write this equation. The sine of 33 degrees equals the opposite over the hypotenuse, CB over 47. To solve this equation, I'll multiply both sides by 47. And I get an answer of 25.6 meters. At this point, you have 2 options for how you can solve. Since we now know 2 of the 3 sides of the triangle, you can use the Pythagorean theorem to solve for the length of AC. You would say that AC squared plus 25.6 squared is equal to 47 squared. Alternatively, you can just use trigonometry again. In relationship to the 33-degree angle that we were given, AC is adjacent, and 47 is still the hypotenuse. So since I'm looking for adjacent and I know the hypotenuse, I would need to use cosine. So the cosine of 33 degrees is equal to the adjacent over the hypotenuse, AC over 47. Multiply both sides by 47, and we find out that the length of AC is 39.4 meters. The easiest thing to do first on our next example is calculate the missing angle measure. Again, because I know one of the 2 acute angle measures of a right triangle, I can add the 2 acute angle measures together and set it equal to 90. So the measure of angle E would have to be 38 degrees. Next up, let's solve for the length of FE. In relationship to the 52-degree angle that we were given, FE is the opposite side, and the 8-inch side that we were given is the adjacent side. So since I am looking for opposite and I know adjacent, I need to use tangent. So the equation that I'll write is that the tangent of 52 is equal to the opposite over the adjacent, FE over 8. To solve, I'll multiply both sides by 8, so FE must be 10.2 inches long. Now let's solve for DE. DE is the hypotenuse of this triangle, and again 8 is adjacent to 52. So since I have adjacent and I'm looking for hypotenuse, I need to use cosine. So I'll write that the cosine of 52 degrees is equal to 8 over DE. That's the adjacent over the hypotenuse. To solve, I need to multiply both sides by the denominator, so I get DE times cosine of 52 equals 8. Multiplying by DE gets the DE to cancel out on the right, but it means it moves over here to the left. So we're not quite done yet. I need to divide both sides by cosine of 52 to get to my answer of about 13.0. For our next example, we can't solve for an angle measure as easily as we did on the other two problems. Instead, the easiest thing to start out with is figuring out the length of the hypotenuse by using the Pythagorean theorem. 2 and 3 are the legs of this triangle because they're the sides that created the right angle. GH is the hypotenuse. So according to the Pythagorean theorem, I can write that 2 squared plus 3 squared equals GH squared. Solve that out, and we find out that GH is approximately 3.6 meters long. Now we need to use trigonometry to figure out the measures of angle G and angle H. Let's start with angle G. It doesn't matter which one you start with, you just have to pick an angle and solve for it. In relationship to angle G, 2 is the adjacent and 3 is the opposite. So that means I need to use tangent, because opposite and adjacent is for tangent. So I'll say that the tangent of angle G is equal to opposite over adjacent, 3 over 2. To solve, I need to use inverse tangent to get rid of this tangent. Since my variable is locked inside of these parentheses, to get rid of the tangent, I need to use inverse tangent. So I find out that the measure of angle G is equal to the inverse tangent of 3/2. And your calculator will tell you that that answer is about 56.3 degrees. You could use trigonometry again to calculate the measure of angle H, or you could just subtract from 90, right? As long as you know one of the two acute angle measures in a right triangle, you can add them up and set it equal to 90. So I find out that H is equal to 33.7 degrees. Our next problem is kind of similar to the one that we just did because the first thing that we should do is calculate the missing side length using the Pythagorean theorem. Always be careful on how you set up the Pythagorean theorem though. For this problem, you don't want to write 8 squared plus 9 squared equals JL squared. Remember that the Pythagorean theorem is a squared plus b squared equals c squared. C has to be the hypotenuse. So the correct equation to write would be that 8 squared plus JL squared equals 9 squared. And solve that out, and we find out that JL is about 4.1 feet. Next, let's solve for the measure of angle K. You could solve for the measure of angle J. It doesn't matter which one you solve for first. You just have to pick one and solve for it, and I'm going to pick angle K. In relationship to angle K, 8 is adjacent, and 9 is the hypotenuse, which means I need to use cosine. So I'll write that the cosine of angle K is equal to the adjacent over the hypotenuse, 8 over 9. I'll take the inverse cosine of both sides and find out that the measure of angle K is 27.3 degrees. Then I can subtract 27.3 from 90 to figure out that the measure of angle J is 62.7 degrees. Alright, I want you to try this next problem on your own. Go ahead and pause the video and solve the right triangle. Alright, let's see how you did. The easiest thing to solve for first is the measure of angle N. I can just subtract 78 from 90 and I find out that the measure of angle N is 12 degrees. Next, I'll use tangent to calculate the length of PM. The reason I'm using tangent is because the length that I'm looking for, PM, is adjacent to the 78-degree angle, and the 56 that I was given is opposite because it's on the other side of the triangle. Opposite and adjacent would be hypotenuse. I'll multiply both sides by PM, and then divide both sides by the tangent of 78, and I find out that PM is approximately 11.9 centimeters. Then I'll use sine to calculate the length of MN. MN is the hypotenuse. And again, PN is opposite from the 78-degree angle, so opposite and hypotenuse, that would have to be sine. Multiply both sides by MN, divide both sides by sine of 78, and we find out that the hypotenuse is 57.3 centimeters long. I want you to try this next example on your own as well. Pause the video and try it now. Let's see how you did. This time the easiest thing to solve for is the missing side length because I know 2 of the 3 side lengths to begin with. So I'll write that 14 squared plus SR squared equals 33 squared. Be careful there with how you set it up. Remember, you don't want to do 14 squared plus 33 squared. 33 belongs on the other side of the equal sign on its own because it's the length of the hypotenuse. Solve that out and you find out that SR is equal to 29.9 miles. Now let's calculate the measure of angle R. In relationship to angle R, 14 is the opposite side, and 33 is the hypotenuse. So opposite and hypotenuse, that would be sine. So I'll say that the sine of angle R is equal to the opposite over the hypotenuse. To solve this, we need inverse sine. Take the inverse sine of 14 33rds, and I get an answer of 25.1 degrees. Then you can just subtract 25.1 from 90 and get an answer of 64.9 degrees for the measure of angle Q. And that's all you need to know about solving right triangles using trigonometry. In the next part of this lesson, we're going to learn how to use sine, cosine, and tangent to solve real-world problems.